Hey everyone, welcome to Selective Prep. Mathematics test number 42. This is the solutions video. So we're going to take a quick overview of a couple of topics that I found are a bit difficult. We may have gone through them before, so if you're fine with these, feel free to skip through a little bit. But otherwise, if you're joining us here for the first time, or if you're still struggling a bit with these concepts, feel free to listen all the way through. So when we have a sequence or a pattern of numbers, then we have a few rules that we want to go through. So 2Ps, either find a pattern or a pair. So when we're given a sequence of numbers, and when we talk about a sequence of numbers, it's a pattern or a number of different numbers that are all smushed together, okay? And we want to try and find a pattern here, because usually what they want us to do is find a certain term in that sequence, okay? So without a pattern, it becomes really time consuming. In terms of sequences or like a range of numbers where they want us to add up and there's no clear pattern, then you want to try and make pairs, which will save you more time than trying to find a weird pattern. And so a good example of a famous pattern that's used is the Fibonacci pattern. It's just the addition of the first two numbers to get to the next number. So you can see here, 1 plus 2 gives you 3, 2 plus 3 equals 5, so on, so on, so on. If they want you to find this term, all you need to do is add up the previous two numbers to get it. So that should give you 34. And then 21 plus 34 gives you 55, so it works. Now, a pattern that I've just randomly put here, made from the top of my head, is just this pattern of odd numbers that you can see. Now, what you want to try and do is try and find a pattern or an equation or a relationship between the position number and the actual term. So the position number here would be like first, second, third, fourth, etc., etc. And then the term would be just 3, 5, 7, 9, etc. And so we can see here, the term is double the position number plus 1 all the time. So what we're going to do is say that x equals 2n plus 1. And if I'm trying to find the 20th term, it's going to be 2 times 20, so 40 plus 1, so it should be 41. That's our 20th term. Now, for example, number 3 that we see here, it's an addition pattern or addition sequence that I've made up as well. So it's similar to the one we had before, but there's no clear pattern, or it's usually quite difficult to find a pattern in terms of addition. So there is one here. I won't go over it because it's too time consuming, but let's go over finding pairs. So in this case here, it's important to know how many terms there are. So in this case, there are actually 25 terms, so we can't make an exact number of pairs without leaving one over. So there's going to be one left out, and let's make it the 1, so it's easier to add on later on. And we're going to make pairs with the first and last term, second and second last term, third and third last term, etc., etc. And what that's going to do is give us the same number, or each pair is going to add up to the same number over and over again. And so we're going to have, so there's 25 numbers here, which means there's 24 numbers excluding the first. And so there should be 12 pairs. So 12 pairs, and each of them add up to the same number, which in this case is going to be 52. Okay, so it's going to be 52 times 12, which should give me 624 if you do the maths. Add the 1, gives you 625 when you add them up. Okay? Now, volumes of cones and pyramids. If you have a cylinder or a prism, not a pyramid, okay, a cylinder or a prism, and you have either a cone or a pyramid with the same base area and shape, plus height, okay, the same height, then it's going to be 1/3 of the volume of that cone, of that prism or that cylinder. Okay, so the cone is going to be 1/3 of the volume of this cylinder, and the pyramid is going to be 1/3 of the volume of this prism. Okay, that's if the base is the same. If the base isn't the same, this doesn't work at all. If the height is different, then you just multiply it by however much the height differs. Okay, so if it's 10, but the pyramid is 20, then it's going to be 2/3 of the volume. If the height of this prism is 10, but the height of this pyramid is 30, then it's going to be the same volume, okay? Now, last thing we're going to go through is simultaneous equations. There's two different types of simultaneous equations, or two different ways of solving these simultaneous equations. So either elimination or substitution. So elimination is trying to eliminate one letter, leaving the other one on its own, so we find what its value is. Substitution is find the value of one letter in terms of the other. So in this case, A in terms of B, and then substitute it in. So we have one equation all in terms of one letter. So let's go through this together. So in terms of elimination, what I'll do is multiply everything by 3 for this equation. So that gives me 3A plus 6B equals 30, sorry. And then I would have a 3A here, which I can eliminate, plus 5B equals 32. So I can just subtract these two together. So 3A minus 3A equals 0. 6B minus 5B just equals B. And then 30 minus 32 equals minus 2. Now, if I want to find what A is, just substitute B equals minus 2 back into here. So A minus 4 equals 10, which must mean that A equals 14. Okay? Now, for substitution, what I'll do is, okay, so I have A, I'm going to move the B over to the other side. So 10 minus 2B. Okay, so A equals 10 minus 2B. I found one letter in terms of the other letter, and I'm going to sub this value of A into here. So instead of A, I'm going to write it as 10 minus 2B. So 3 times 10 minus 2B plus 5B equals 32. And what that gives me is 30 minus 6B plus 5B equals 32, which is 30 minus B equals 32. Move the 30 over, should give me minus B equals 2, B equals minus 2, and then same process of finding A. Okay, so they should give you the same answer, essentially. Now, let's get started straight away. So we have a cube that holds 1 liter of water. We have the same cube here, so that's 1 liter. Okay, and then we have a pyramid. So that should be 1/3 of the volume, but it's 20 centimeters in height. So double the height of the cube, which means it's going to be 2/3 of the volume. So 1 liter and 2/3 of a liter, which is 1.6666. If you round that up, should give you 1.7. It's close to 1.7. Now, we have a question where there's a person, Angela, who has a discount voucher for fuel. First 50 liters is going to be 125.5 because it's 20 cents off. Second, the last 10 liters is going to be the regular 145.5. Okay, and so if we try and find how much the 10 liters was, it's going to be 14.55, and for the 50 liters, it's going to be, let's do times 100 divided by 2. Because we want to really use these mental tricks to be able to solve things faster. So 125.5 times 100 is going to be $125.50, and then divided by 2 is going to give you $62.75. Add these two together, you should get something really close to 77, just over 77. Okay, question 3. Let's take this step by step because this problem solving question is a bit difficult, and I'll explain to you how we should be approaching this question. So PP and then QQ and RR adds up to QPR. So before we take a look at anything, let's find what this Q can be. So if we have three 2-digit numbers, okay, and we add them all up, and even if they were all 99, 99, 99, which they can't be, so it has to be 99, 88, 77, okay, the largest number that Q could be is 2, because it would add up to 290 something, okay, it would add up to 297, so even if they were all 99, Q could only be 2, so Q either has to be 1 or 2, right, so PP, QQ, so QQ either has to be 11 or 22. In the case that QQ is 22, so P and then 22 and RR, okay, if PP was 99 and RR was 88, this would still only add up to 100 and something, okay? It would be 190 something, like 198 or something along those lines, but it would still be, or it might be 199, but it would still be in the 100s. So Q, even if Q was 2 here, Q would only be 1 here, okay, which must mean that Q cannot be 2, because if Q is 2 here, it'll still add up to 1 here, it doesn't work. So Q has to be 1. So in this case, so P and then Q is 1, 1, and then RR. In the case where we have QPR, P plus 1 plus R equals R, which must mean that P plus 1 has to equal 10. So P equals 9 in this case, okay? So P equals 9, Q equals 1, so P plus Q, which is what the question is asking, equals 10. So if you went too far ahead and then read the question a bit later and you're like, oh, what's going on? Okay, this is important because it shows you that reading the question is really important. Now, question 4. So Jonathan's making patterns using matchsticks. So we have a pattern here where we have the first pattern, which is a triangle, so 3, and then every time we move on to the next position, we just add on 2 matchsticks. So 2 and then n minus 1, right? So on the second position, we're not adding 2 lots of 2. Okay, so we need to account for that. So the matchstick, what would the matchstick be in the 30th? Oh, how many matchsticks would there be in the 30th shape? So we'd have 3 plus 2 lots of 29, not 30. Okay, because this first position, we're not adding 2 matchsticks onto this. So it'll be 3 plus 58, which should give me 61. Okay, so this is 58. Now, a centimonth is, let's say a month is around 30 days. It could be 31. It's going to give you roughly the same answer in this case. So 30 divided by 100, okay, in terms of days, is going to be 0.3 days. Now, in a day, there is 24 hours. So let's find out how many hours there are. Now, quick maths again. I'm going to multiply by 3 and divide by 10, because that's the same as 0.3, but it's easier to do in my head that way. So 24 times 3 is 72 divided by 10 should give you 7.2 hours, which is closest to B. Question 6, so we have patterns and sequences with blocks here. Each block is equal to or has a side of 7 centimeters, which is important to read, otherwise it would have been confusing. Now, the pattern is go down to move 1 to the right. So it's called 2 1 stairs. Now, if we wanted to make the stairs 42 centimeters long, so length is across this way and then height is this way, it's already 21 centimeters long. So we need to add 3 blocks more. Okay, now on this row we would have a 5 block row or a 5 block high, and then here we would have a 3 block high, here we would have a 1 block high. So we would have 5 blocks plus 3 blocks plus 1 block, which is going to be 9 extra blocks to be able to make this 42 centimeters long. Question 7 is volume. So if the volume of a cubic block is equal to 343 centimeters, what is the total volume of the 2 1 stairs? So far we have 11 blocks here, 9 blocks here, and then 7 blocks, which is 27 blocks altogether. Okay, if we do 343 times 27, you should get E, 9,261. Okay, I'm not going to do the long multiplication for you because you guys already know how to do that. Question 8, area. How many faces could you see on the 2 1 stairs? So if we look back, okay, we have 11, 9, 7, so 27 blocks. So at the front, okay, if we look at it from the front, that's 27. If we look at it from the back, that's another 27. If we look at it from the side, that's 11. If we look at it from the other side, it's 11. If we look at it from top down, it will be 3. Okay, so remember, we can't look at it from bottom up because it's on the floor. And the opposite sides of these 3D shapes are always going to have the same area exposed. Okay, so we're going to see the same. If we look at it from any side, it's going to be the same as looking at it from the other side. Okay, so it's going to be 54 plus 22 plus 3, which is 76, plus 3, which is 79. Is that one of the answers? Yes, 79 faces. Question 9. So we have Peter, who's planning to buy a bag of lollies. He wants to buy 1 kilogram only. So bag A is 2.125 per kilogram. And then bag B, 590 divided by 2.5. Let's divide it by 2 first. Actually, let's not do that. Let's divide it by 5 to see what 0.5 kilograms is. So 5.9 divided by 5. So 0.5 kilograms is equal to 1.18. So 1 kilogram equals 2.36, which means that bag A is cheaper by about 23-24 cents. Okay, so that's E. Now, we are going to use simultaneous equations again in this question, just because it's just trial and error otherwise. So you can use trial and error and get it, but it's going to be not such a great way of doing it. So x is a square. X here is a square, which must mean each side is the same. So we're going to call each side x and x. Y is a rectangle. So I'm going to call the longer side y and the shorter side z. Okay. Now, we know x times y equals 84. We know that x times z is equal to 28, and we know the perimeter of rectangle y is 32. So y is 2y plus 2z equals 32, which must mean that y plus z equals 16. Now, I want to try and find, using these two, an equation in just y and z, because this one's in y and z as well. So I want two equations in y and z. So here, I'm going to try and cancel the x's out. So x equals 84 over y if I move the y over to this side, because it's a time. So when you move it over, it becomes a divide. And in this equation, x equals 28 over z. So 84 over y equals 28 over z. So z, 84z equals 28y. So y equals 3z if you cancel out the 84 and the 28. Okay, so y equals 3z, which must mean that 3z plus z equals 16 if we sub it back in here. So 3z plus z equals 16, z equals 4, which must mean y equals 12, which must mean the area of rectangle y, which is 4 times 12 equals 48. Last question. So in these blocks, we have the same number of blocks and they're all the same size. So it says equal number of identical triangles, which must mean the area is the same. But if you look at the perimeters, it's 4, 4, 4, 4, which is 16. Here it's 1, 2, 3, 4, 5, 6. So 6, 6, 4, 4, which is not 16. Okay, it is 20. Okay, so same area, different perimeters. All right, so that ends our solutions video for today. Okay, I will see you guys in the next video. But for today, have a good rest of